Okay, we are in motion in one dimension. So in that motion in one dimension, we already talked about distance and displacement, speed and velocity, and then we talked about average velocity. And in that average velocity especially, we talked about two important things there. If a body is moving half of the journey time with velocity v1 and half of the journey time with velocity v2, then the average velocity is given by v1 plus v2 by 2. And this is, keep in mind, half of the journey time. Directly you can, if you remember the formula, directly you can apply that. And half of the distance, half of the journey with velocity v1 and half with velocity v2, then the average velocity is 2v1 v2 by v1 plus v2. Okay, this we have learned, and hope this is in your brain, right? And then we talked about instantaneous velocity, and just remember the formula for instant. And later, after in your mathematics, you will learn about differentiation, and then you can understand clearly what is the meaning of or how to go with this ds and dt. So instant velocity v is given by ds by dt. Just remember this formula. Later we will understand how to go with it. This is the formula for instantaneous velocity. I think you remember the meaning of the, or definition. Meaning or definition. The meaning put in the words is the definition. Okay, no need to by heart these definitions or anything else. Velocity at a particular time. If the body is moving with variable velocity, the velocity at a particular time or at a particular point is called as instantaneous velocity. So we talked about that, and then we were talking about the graphs, and first we talked about position time graph. Position time, or we will be calling it as displacement time graphs. Either this can be called as xt graph or this can be called as st graph. Both mean the same. Right. And when we will be calling a graph as the displacement time graph means, suppose if a graph is there, you know very well how to make the graphs x and y. So here time is taken on x-axis and the displacement or position taken on y-axis. These graphs are said to be the displacement time graphs. So here, first we have taken an example there. If a body is at rest, how the graph will be? The graph is a straight line parallel to x-axis. So body is at rest. If the body is at rest, graph is, which graph? St graph is a straight line parallel to x-axis. And from this, if a graph is a straight line parallel to x-axis, it means that its slope is 0. In mathematics, you might have learned about this. If it is a straight line parallel to x-axis, its slope is 0. Okay, anyhow, we will discuss once again. What is the meaning of the slope? It is an inclination or angle made with x-axis. We will be calling it as the slope. So here, if it is parallel to x-axis, what is the angle made with the x-axis? So there is no angle. If it is parallel to x-axis, and them is 0. So what is the meaning of slope? It is the inclination made with the x-axis. Okay. So here body is at rest. Then its slope is 0. It means that what is 0 for this body? Its velocity is 0. Its velocity is 0. So because slope is 0, its velocity is 0. So from this we can understand one thing. Slope of ST graph gives you velocity. Slope of ST graph gives you velocity. Okay. So we have extracted a very, very important point here. Slope of ST graph is giving you velocity. Okay. So now we have taken one example, one situation here, and we have just made a graph for this like this. We'll go for another case. If it is not parallel to x-axis, but it is a straight line. Look here. If this is the graph, it is a straight line, but it is not parallel to x-axis. It means that the graph is like this. The graph is like this. So now this is ST graph, isn't it? So time taken on x-axis, displacement on y-axis. From this graph, what can we say about the motion of the body? Look at here. This graph is like this. That means we just make the points here. If this is 1, this will be equal to 1. If this is 3, this will be equal to 3. If this is 5, this will be equal to 5. Isn't it? That means we just make a table here. Look at displacement will be in meter, time will be in second. So 1 meter, 1 second. The body is at 3 meter at 3 seconds. 4 meter, 4 seconds. So from this data, you can understand that equal displacements in equal time intervals. So the velocity is uniform. How did you say that? It is equal displacements in equal intervals of time. So by seeing this, you understood that the velocity is, you look at between 1 meter and 3 meter, it is 2 meter, and this is for 2 seconds, and this is for 1 meter, 1 second. That means for every 1 meter, the body is covering 1 second. Equal displacements, equal intervals of time. Equal displacements, equal intervals of time mean that the body is having uniform velocity. So whenever you find a graph like this, displacement time graph, a straight line like this, and it is not parallel to x-axis, then straightforward you can say the body is moving with the uniform velocity. Straight away by looking at the graph you can say the body is having uniform velocity. And here one more thing you observed here. The body is starting from, the graph is starting from origin. If the graph is starting from the origin, that means displacement is 0 and time is 0. That means the body is starting from rest. Okay. So now, so the body is starting from rest, or else we can go like this. Now here, anyways here, so here, from this if you find a graph is a straight line and is at an having an inclination with x-axis, then the body is having uniform velocity. So from this graph we need to calculate the velocity. From this ST graph we need to calculate the velocity. How to calculate the velocity from ST graph? Already here we just got an information here. Slope of ST graph gives you velocity. So finding the slope of ST graph gives you velocity. Now, how to find the slope of the graph? That is the question here. Already, if you are good in mathematics, easily you can, now itself you can, directly looking at there, you can say, what is its slope? Okay. Anyways, here, once again, we'll go with this. How to find the slope of the graph? Slope of a graph, a line. Here, look at it. Here, the formula is, slope is y2 minus y1 by x2 minus x1. Difference in y-intercepts by the difference in x-intercepts, okay? Okay, now, in this graph here, look here. Suppose if, let us take here, I want to find the slope of this graph. So this is the point. So here we have one point. And here I have one more point here. Origin we can take easily because we know very well what are the points of the coordinates of the origin. 0, 0. And let this be some like and this is 2 and let this be 10. So 10, sorry, first we have to write the x coordinate 2 and then the y coordinate 10. Look at here, in this, for this line, the first one is x1, y1, and for this it is x2, y2, okay. So now, what is the slope of the graph? y2 minus y1 by x2 minus x1. So this is x2, y2 is here, 10. So it is 10 minus x1. x1 is 0 from origin. And x2 is here, 2. And x1 is 0, it is 10 by 2, so it is 5. What did you find now? The slope gives you velocity. We should not leave the answer as 5 because it is a physical, it is the magnitude and this is a physical quantity and this should be followed by the unit. The distance is in meter and the time is in second, so 5 meter per second. Okay. So like that we can find out the slope of the graph or the velocity using displacement time graph. So by this you can, now you might have got a point what we have left earlier. What is the significance of these graphs? Yes, from this you might have understood the two things. One is we can, by looking at the graph, we can say the status of a body. That means how the motion of the body is. That's the first one. And the second one is, by looking at the graph, ST graph, you can talk about its velocity. By just telling its slope, you can talk about its velocity. So two things you can find out using this graph. One is we can talk about the motion of the body, and the second one is if it is an ST graph, we can find out its velocity here. And we'll go with one more example for recording the slope. Suppose if this is an ST graph, a graph is like this, and here it is 2, and it is, let it be 12, so time is in seconds, and this is 4, and this is 14. So displacement is in meter, time is in seconds. So now, by looking at the graph, it is asked to find the velocity. What is the velocity of the body? First of all, see whether the body is having velocity or not. As it is a straight line and it is not parallel to x-axis, so certainly the body is moving with uniform velocity. If it is moving with uniform velocity, what is the velocity? Yes, by finding its slope, y2 minus y1 by x2 minus x1. So what is x1, y1 here? This is the first point, and this is x1, y1, and this is the second point, x2, y2. So y2. So let us write the coordinates here. For this point, the coordinates are 12 and 14. First write x coordinates, then write y coordinates 12, 14. What are the coordinates here? 2, 4. First write down the x coordinate, next write down the y coordinate, 2, 4. Now substitute in the formula here. This is 14 minus 4. 12 minus 2. It is 10 by 10 and it is 1. From this we have calculated the velocity, and the velocity we have to write the units, meter and second, 1 meter per second. Okay, so I think you now clearly understood how to write down or how to find out the slope of the graph. Okay, now if the body, from this graph we understood that the graph is just having the positive inclination. So that's why if the body is moving with, simply set with velocity. So suppose if the displacement time graph here, if the graph is like this, as it is also uniform velocity, but the velocity is in negative. Okay, so this is one type of the graph, and we'll just go with one more example here. If this is a displacement time graph, and if the graph is not a straight line, but it is like a curve like this. So here, if it is not a straight line, then the body is said to be not having uniform velocity. So it is non-uniform velocity. Okay, so that is about this displacement time graph. That is about this displacement time graph. Now pause the video and take the screenshot of this. Okay, for here one more thing we have left here. So if it is a displacement time graph, and if the graph is like this, the body is moving with non-uniform velocity. If it is moving with non-uniform velocity, this will be otherwise calling as the variable velocity. That means the velocity is not uniform, it is changing, variable velocity, right? Okay, now that means at each and every point the velocity may not be same. Okay, so now how to find the velocity for this? Because it is a straight, earlier it was a straight line, and there simply you just use the formula y2 minus y1 by x2 minus x1 by selecting any 2 points, one as x1 y1, other as x2 y2. So y2 minus y1 by x2 minus y1, it did the problem and completed it and got the answer and told it as uniform velocity. Finished. But in this case, here how can we go? Can we go with the same method? No, it's not possible. So what we are going to do is, here we talked about if the velocity is changing, we can find the velocity at a particular point, instantaneous velocity. So now, suppose if we want to find the velocity at this point, what I have to do is, this is a curve, right? This is a curve. What I'm going to do is, I'm going to draw a tangent at that point. I'm going to draw a tangent at that point. I think you know the tangent, I think. If this is a curve, that means it is a part of a circle, and draw a radius, and the line which is perpendicular to that is called as the tangent. So, drawing a tangent. Now we got it this as a straight line. For this straight line, we will select one as x1 y1, another as x2 y2, and then we go with the formula y2 minus y1 by x2 minus x1. Okay. Suppose if you want to find the velocity at this point, you have to draw a tangent here. Look here. The slope of this is different from the slope of this. Look at this. Look at this angle here. This angle is different, and this angle is different, isn't it? So by this you can understand that it is moving with, slopes are different, velocities are different. That means the body is moving with variable velocity. Understood? Right. So now, at this point, what you're going to do is you will be drawing a tangent, and for the tangent you will select 2 points, and you will mark it as x1 y1 and x2 y2, and then you will go for solving the problem. Okay. Right. And this is regarding displacement time graph. And next From the displacement time graph, we understood the significance of displacement time graph. One is we can talk about the motion of a body. Other one is we can find the velocity by its slope. That is the significance or importance. Okay, right. Now coming to the velocity time graphs. We'll be calling these as the VT graphs. The same thing, but with a small change here. Here, this time taken on x-axis and velocity taken on y-axis will give you what is that? Velocity time graphs. So in this case, if you find the graph which is a straight line parallel to x-axis. Earlier also we have seen this in the case of displacement time graph, and we said that the body is at rest. And here, if it is a straight line parallel to x-axis, can we say that the body is at rest? Let us see the data here. So here at this place on this y-axis, let this be velocity will be meter per second, right? So it is 5, and here let the time be 1 second, and let here the time be 5 seconds, and let here the time be 10 seconds. And if you just write the data, velocity in meter per second and the timing second. So at 1 second, its velocity is 5 meter per second. At 5 seconds, the velocity is 5 meter per second. At 10 seconds, it is 5 meter per second. That means the body is having the same velocity. Velocity means it is changing its position in a particular direction. Isn't it? So now, for every time interval here, for every as the time goes on, the velocity is remaining same. That means this is uniform. That means the body is having uniform velocity. The body is having uniform velocity. So now, from this we understood one thing. If the graph is, which graph? VT graph. If VT graph is a straight line parallel to x-axis, and then you can say body is having uniform velocity. Uniform velocity. Okay, now let us talk about one more thing here. Here, the velocity is not changing. As the time is changing, the velocity is not changing. That means rate of change of velocity is 0. The rate of change of velocity is 0. That means change of velocity with respect to time is 0. Rate means with respect to time. This is 0. That means the velocity is not changing. What is the rate of change of velocity? What does this tell to you? This tells about acceleration. Acceleration here. So here acceleration is 0. So graph is a straight line parallel to x-axis. The rate of change of velocity is 0. Acceleration is 0. If it is a straight line parallel to x-axis, its slope is 0. That means slope is giving you the acceleration. From this we can draw an important point, that is slope of VT graph gives you acceleration. Slope of VT graph gives you the acceleration. Now let us talk about, now we understood here the importance of this VT graph. First one is, as usual, it can give you the information regarding the motion of a body, what type of motion it is, whether it is moving with uniform velocity or non-uniform velocity or something else or something else. And other one is it will tell you about its acceleration. Let me go with one more graph here. It is a straight line but not parallel to x-axis. That means having some inclination with the x-axis. By looking at this, we can say it is having the velocity is not uniform, isn't it? It is not uniform. So look here, if you can understand it here. On y-axis, the velocity is changing continuously, isn't it? Just here, look at the velocity is changing continuously. As the time is going on, the velocity is changing. And if you just see if it is when it will be a straight line, if the velocity is changing at uniform rate, that means as the time is changing, the velocity is changing with the uniformity. That means at equal changes. That means the rate of change of velocity is giving you acceleration. That means velocity is not uniform. So here, but rate of change of velocity is uniform. If rate of change of velocity means, what is the meaning of this? This is nothing but acceleration. So that means acceleration is uniform. Acceleration is uniform. So the graph is a straight line and it is having inclination with x-axis. So we can directly say it is uniform. And you know how to find the acceleration for the graph, just finding its slope. How to find the slope? y2 minus y1 by x2 minus x1. So we'll continue this in the next session.